I'm saying it could be a black swan event where we expect it most likely to be a natural object, but we have to attend to the possibility that it might not be natural just because the implications would be huge for humanity.
We are standing before a true black swan event of the new century, something no one should have seen coming yet, can no longer ignore. At 22:06 UTC on November 15, 2025, from a quiet corner of the night sky, Terasak Theluwangan, amateur astronomer representing Thailand Observatory, Rayong, Thailand, recorded a striking anti-tail along with two sharply defined tails erupting from the third interstellar object ever discovered. This means the anti-tail has remained shockingly stable and unnaturally persistent for 1 month. If 3I Atlas were an ordinary comet, its structure definitely would have blurred, and now it's no longer a matter of one team's report or a single country's data. The entire world is witnessing the same anomalies with its own eyes. These are the latest revelations about 3I Atlas as of right now. And this time it wasn't the United States, Europe, or even China could touch the mystery. It was Thailand, a small nation in Southeast Asia, with nothing more than a 26-meter telescope. Terasak Theluwangan captured the breakthrough moment of the universe. Before we get into a deeper analysis, I'd love to have the support of all of you who share a passion for uncovering the mysteries of the universe. A follow goes a long way. Thanks so much for that. Now let's look closely at this image. Everything described can be seen clearly with the naked eye, requiring no scientific interpretation at all. On the left, a sun-facing anti-tail. On the right, two separate tails stretching outward into space. The anti-tail is bright straight, sharply defined, its stability unmistakable. More astonishingly, it has not faded. It has grown stronger as Atlas approaches the sun. This is not behavior we should expect from a natural comet. David Jewett's research group proposed that the anti-tail may be made of massive dust grains 1,000,000 times heavier than those of ordinary comets. But Professor Avi Loeb immediately pointed out major flaws. If that were true, the current brightness would require the dust ejection rate to increase 100-fold compared to micrometer-sized particles. That would imply a mass loss level far exceeding the already generous 13% estimate, completely inconsistent with known interstellar comet behavior. Another possibility suggested by Loeb and collaborator Eric Keto involves large ice slabs being expelled and fully vaporizing before radiation pressure pushes the material backwards. But even this scenario demands highly unusual gas dust dynamics that have never been observed before. And then comes the boldest hypothesis, the one we fear the most, that these streams might be the product of thrusters or engineered jets.
Some of them towards the sun, some of them away from the sun. What surprises me is that they are tightly collimated, and that is surprising because the object is rotating. The last time we checked, it has a rotation period of only 16 hours.
Loeb further emphasizes that despite recent observations confirming that 3I Atlas is still rotating, its jets remain perfectly straight, ultra-narrow, and aligned, maintaining their direction across millions of kilometers. This phenomenon is profoundly abnormal, and thus he classifies it as the 12th anomaly of this interstellar visitor, one more mystery in a growing list that defies every rule we thought we understood. By fundamental principles, when a comet's nucleus rotates, its jets sweep outward in spirals. Over distance, these streams disperse. They cannot maintain a straight axis for long. After just a few thousand kilometers, the material fan spreads dramatically. This is the complete opposite of 3I Atlas. Scientists emphasize that this 12th anomaly is highly unpredictable. Numerous hypotheses have been proposed, and Avi Loeb highlighted 4 main possibilities in his latest report. First, the escaping gas might have slowed the object's rotation from July to the present. Loeb rejected this, noting that if the gas were ejected asymmetrically, the torque should increase the spin, not slow it down. Second, he suggested that ice pockets hidden in valleys shadowed by terrain sublimate only when sunlight hits at precise angles. This could produce pulsed jets every 16.1 hours, forming a pearl chain of materials spaced 23,270 kilometers apart. While this mechanism might explain a sun-facing jet, it cannot account for a tail pointing away from the sun. Images from November 8th show that 3I Atlas has both sunward and anti-solar jets, completely invalidating this idea. Finally, Loeb considered that the jets could be evaporation trails of fragments ejected during a near-sun explosion. Yet images from November 11th by Jewett and Liu show the nucleus remains a single intact body with no evidence of large detached fragments. In short, all traditional natural models fail when applied to 3I Atlas. This leaves us with a stark choice: either we embrace a new kind of natural phenomenon, or we entertain the bold and once dismissed possibility of a remnant of extraterrestrial intelligence. Previously, I shared a video detailing the 10 suspicious anomalies of this object. We've just discussed the 12th anomaly. So what about the 11th anomaly? It is closely linked to the 12th. This anomaly concerns 3I Atlas, surviving perihelion intact despite facing extreme heat and intense solar radiation. According to Professor Avi Loeb, the comet exhibits non-gravitational acceleration that implies it should have lost more than 13% of its mass. Yet astonishingly, its nucleus remained fully coherent, enduring conditions that would have destroyed a typical comet. This resilience is what makes the 11th anomaly so extraordinary and directly sets the stage for the 12th. In natural comets, internal outgassing forces generate significant stresses on the surface, gradually widening pre-existing fractures that have formed over billions of years. Comets are typically most active at perihelion, where the combination of solar heating and volatile sublimation drives these cracks to expand rapidly. For a strongly active comet, this process almost inevitably leads to fragmentation. And yet 3I Atlas remains a single coherent body, not like a real comet. The question is, why an object measuring just 5.6 kilometers in diameter should have been shredded by the sun's powerful forces? So scientists may have made a miscalculation about the size. Professor Avi Loeb presented a new calculation that reveals a strikingly different picture of Atlas. According to him, the comet's actual diameter may need to be 4 times larger than previously estimated, meaning its nucleus could be a sphere 23 kilometers across, far exceeding the measurements suggested by Hubble Space Telescope images. It suggests that what this beyond-the-star object may be far more extraordinary than previously thought. With the tail extending 0.95 million kilometers toward the Sun and 2.85 million kilometers in the opposite direction, he and his close research team estimated that the amount of gas and dust being ejected must be enormous, implying an extremely high mass loss rate. This in turn necessitates comparing the energy required for sublimation to understand how such vast amounts of material could be released, highlighting just how extraordinary 3I Atlas's activity truly is. Professor Avi Loeb has analyzed the numbers with meticulous detail, breaking down the absurd activity of this object in a way that is both rigorous and surprisingly accessible. He begins by considering the expected outflow velocity of water jets for a natural comet. For a typical comet, this speed should reach about 0.4 kilometers per second, which coincidentally is roughly the speed of sound for gas at a distance of 1.43 astronomical units from the Sun, where 3I Atlas currently resides. Loeb emphasizes that if these jets maintain such a relatively slow and stable velocity, the comet's tails must persist for 1 to 3 months, stretching across the vast emptiness of interstellar space to account for the observed tail lengths. Using Atlas's anti-tail as a concrete example, Loeb demonstrates how solar wind interactions shape the comet's structure. The anti-tail, he notes, is deflected and bent by the solar wind roughly 1 million kilometers from the nucleus. At that distance, the proton density in the solar wind reaches 2 to 5 million protons per cubic centimeter, so it is sublimating up to 5 billion tons of material per month from regions of the nucleus spanning roughly 1 million kilometers on each side. And you know the rate of material loss is comparable to a massive waterfall of Niagara, but on an interstellar scale. Unlike a terrestrial waterfall, however, this is not water cascading down a cliff. It is gas and dust blasting into the vacuum of space from a single interstellar object, continuing relentlessly every second for an entire month. The sheer scale of this outflow is almost incomprehensible. According to thermodynamics, sublimating carbon dioxide ice requires 600 joules per gram. If 3I Atlas expelled 5 billion tons of carbon dioxide in 1 month, the total energy would reach an astonishing 3 times 10 to the 18 joules. By comparison, the solar energy available at perihelion is only about 700 joules per square meter per second, meaning the comet would need a solar-absorbing surface over 1/600 square kilometers to sustain such outgassing. That's why we have the figure of 23 kilometers in diameter of the nucleus. Natural comets do not have fully active ice-covered surfaces. Volatile ices exist only in small pockets. Even with generous size assumptions, no physical mechanism could generate enough energy to drive such extreme mass loss without shattering the comet. If Atlas were primarily water ice, the required diameter would balloon to nearly 51 kilometers times larger than Hubble's estimate. This paradox shows that Atlas is simultaneously too small to produce the observed mass ejection, yet too resilient to be destroyed, defying conventional comet models. Considering Atlas differently, its activity may be independent of sunlight or standard sublimation. It could draw on internal energy chemical reactions, radioactive decay, or even an unseen propulsion mechanism allowing it to eject material at extraordinary speeds and volumes. The jets themselves are structured not random, stretching millions of kilometers while maintaining organization rarely seen in natural comets. This gives the anti-tail and elongated jets an almost engineered appearance, suggesting deliberate regulation of material ejection. If these observations are accurate, 3I Atlas is far more than a frozen wanderer drifting through space. It behaves like a mysterious traveler with latent power. Where other comets expel material like a basic engine, Atlas seems capable of propulsion more akin to a rocket with precise, far-reaching jets. Science, of course, is ultimately about testing hypotheses. Proposing bold ideas is not mere speculation, it reflects careful observation questioning and efforts to understand phenomena that defy conventional explanation. Each hypothesis brings us closer to grasping the extraordinary nature of this interstellar visitor, 3I Atlas, and highlights how interstellar space challenges our understanding of cometary behavior. Excitingly, NASA will soon release high-rise images captured on October 3rd, the sharpest and most detailed views ever obtained of Atlas. These high-resolution images will allow scientists to refine estimates of the nucleus size, potentially confirming or adjusting Professor Loeb's extraordinary calculations. Researchers will also be able to examine the unusual sunward-directed jets in unprecedented detail, studying their structure, orientation, and intensity. The images may reveal clues about the comet's chemical composition, including unusual elements or compounds resembling metals or alloys rarely seen in natural bodies. This could shed light on the processes that shape this interstellar traveler over billions of years. Ultimately, these upcoming observations will provide an invaluable opportunity to test the many hypotheses surrounding 3I Atlas. From its size and structure to its outgassing mechanisms and composition, every detail captured by HiRISE will help the scientific community understand why this object continues to challenge conventional models of cometary behavior and why it remains one of the most fascinating and mysterious interstellar visitors ever observed. It'll be updating the latest images continuously. Turn on notifications so you don't miss a thing,